Hi everyone, welcome to today's webinar, Make Your Java Dev Team More Productive with AI-Led Unit Testing, sponsored by Parasoft. I'm Jenna Barron, news editor of SD Times, and before we get started, I have a couple of quick housekeeping announcements. First, this webinar will be recorded and available on demand through the sdtimes.com website in about 24 hours. Second, if at any time you have questions about or during the presentation, you can submit them using the chat feature. And finally, we have a couple of free downloads that will be shared throughout the presentation. So if you go to the right-hand side of the screen, there's a handouts tab next to the chat, and that's how you'll access those. Our speakers today include Nathan Jakubiak, Senior Director of Development at Parasoft, and Brian McLaughlin, Senior Software Engineering Lead at Parasoft. Now to get things started, I'll turn it over to you, Nathan.
Great, thank you very much. Welcome to our webinar. As she mentioned, I'm Nathan. I've been at Parasoft for about 22 years now. I'm a Senior Director of Development that leads multiple distributed development teams for Parasoft around the world, primarily in the areas of functional testing, such as API testing and service virtualization, as well as Java unit testing, which we'll be discussing today. Brian, do you want to introduce yourself?
Sure. I'm Brian McLaughlin. I am a senior software engineer at Parasoft. I've been with Parasoft for about 15 years myself, and I'm a team lead working primarily with Jtest and the unit test assistant.
Excellent. Thanks, Brian. We'll hear from you in a little bit. So today, what we want to discuss is how we at Parasoft, as well as a number of our customers, use our Java developer test productivity solution, also known as Parasoft Jtest, to increase the productivity of their development teams, to maintain high levels of quality as they're pushing out functionality, while minimizing the cost that it takes to do their software development. As we're discussing productivity, we're specifically focusing on productivity in the unit testing practice, since unit testing seems to be a practice that's expensive to do well. If you talk to people in the industry and to different teams, estimates are that it can take somewhere between 25 to 50% of a development team's time to write and maintain their unit tests. So while most people would agree that it's an essential practice to ensure the quality of an application, it also is very expensive. So what are the primary challenges that teams face related to unit testing? One is that when we create unit tests, we want to create tests that are meaningful and appropriately test the code for different valid use cases. And that can be difficult depending on what the code looks like. Oftentimes, teams have coverage goals that they want to achieve. They might have set something like an 80% coverage goal or something. And writing all the tests it takes to get there can take a long time. And then once you have a suite of tests, maintaining that test suite comes with a cost, because when tests fail, you have to triage them and decide how do you handle those failures, whether you need to update your code, you need to update your tests, and so on. So all in all, the unit testing practice tends to be quite time-consuming if you do it well. It requires knowledge and sometimes specialized knowledge. So, when you're creating certain levels and complexity of unit tests, you need the right kind of knowledge to do it well. And then in the end, it ends up that unit testing, although it's kind of counterintuitive, sometimes it conflicts with the priorities that are in development, because teams feel like they have this pressure to continue building new functionality into the software. They have deadlines they need to meet. And sometimes testing, and unit testing in particular, can seem like it conflicts with the need to build the new functionality. And so oftentimes unit testing gets deprioritized, even though most people would agree it should not. So if your organization is anything like ours at Parasoft, you probably don't have the resources to do everything that you really want to do. At Parasoft, we have very aggressive release schedules. We always have lots of functionality we're trying to pack into our releases, trying to help our customers as much as possible. And at the same time, we have a very high commitment to quality. So everything we release needs to be high quality, it needs to work well. But we have constraints, right? We have constraints around how much time it takes to do these things, and we never feel like we have enough time. We never feel like we have enough resources to do all the great things that we want to do. And I would imagine that most development teams feel like that. So in that kind of an environment, we really have to figure out how can we do more with less? How can we accomplish everything we want to with the resources that we have? So to set the stage, let me explain to you what kind of practices and metrics that we use in our development teams at Parasoft to ensure the high quality. Generally, we have a requirement that all new and modified code that we develop needs to have 80% code coverage. This ensures that the code is highly tested, and I'll go into that in a moment. We have continuous builds because we always want a potentially shippable product. We do run static analysis. I'm not focusing on static analysis today, but we do use the tool I'm going to be talking about to also run static analysis, including different like OWASP top 10 security rules to check for coding patterns and make sure that we're following good practices and not violating bad coding practices. We have a large suite of different kinds of tests, from unit tests to API tests, a functional test, to even user interface tests. And we have a set of criteria that we use. So for instance, we have a build promotion process that tries to decide whether a nightly build is good enough to share with others in the organization. And that build promotion process requires us to have no static analysis violations and 0 unit test failures. Similarly, when we get to a release, we're required, in addition to that criteria, we're not allowed to have any failing tests of any kind, including our functional tests, our API tests, and so on. And so, we have a very high commitment to quality to ensure that when we build and release our software, that it works the way that it's supposed to. So since it can be challenging to achieve these high levels of quality and still maintain good productivity in our development, today we're going to talk about 4 different techniques that we use, as well as our customers use, that help us to achieve the levels of productivity that we want. And to do that, we're going to be talking about how we do that with Parasoft Jtest and a feature in Parasoft Jtest that we call the Unit Test Assistant. If you look at typical development projects, they kind of split in 2 different ways. I would say probably a majority of our projects have a lot of legacy code. So, and this is true at Parasoft. I think it's true for a lot of our customers as well, where we're maintaining or building onto existing applications with lots of legacy code. In addition, we could have some projects where we're starting net new from scratch. So maybe in those projects we're building with, it's just totally new code. In projects like that, it tends to be easier to get started. You could start with good practices and high levels of test coverage from the very beginning. With legacy code, that can be quite a bit more challenging. And then often projects are really kind of merged, right? Oftentimes your legacy application, you might have parts of it that work really well. You don't need to touch that. They do what they're supposed to do, so you leave those alone. But then there might be other areas where you need to add new features and new functionality. And then there's a mix of, adding new code to the legacy code. So let's first talk a bit about, the challenges with legacy code. Michael Feathers wrote a book called Working Effectively with Legacy Code. And in that book, he defined legacy code as code that has no tests. And really, that's the issue, right? Legacy code is not an issue just because it's old code, right? If it's written well, hey, that's great. The issue is when your legacy code doesn't have tests, because as soon as you start changing the code that has no tests, at least me as a manager, I get afraid, right? I don't want to make changes without knowing that I'm not going to break the application. And that's the real problem with legacy code. So, we have 2 options there. Either we could decide not to make changes, but from the business, that's usually not an option. So the next question is, how do we make changes in a way that's safe and that we have the confidence to make those changes? So the first technique that I want to discuss that we and our customers use with Parasoft Jtest is to generate a suite of unit tests for our legacy code. So the way that this would work is in Jtest, we would run a simple action pointing it at a project that has no tests or has few tests, and you tell it to generate a large suite of tests. With a single simple action, these tests often will cover about 60 to 70% of the code. And the good thing about these tests is they're written in a style that feels like an actual person wrote them. So they feel like human written tests. And what the purpose of these tests is to capture the current state of the application. So these tests are designed so that they cover as many different code paths as possible. They have assertions to validate the behavior of the code. And this creates effectively, it's a regression test suite that alerts you. So if you make changes to the code that change the behavior, then these tests would catch it and alert you. So then you know, you can figure out how you need to respond to that. And this basically gives you a safety net, right? It's a safety net that allows you to modify your legacy code with confidence, knowing, hey, if I change the behavior in an unexpected way, I'm going to find out. I'm going to know about that. So let me talk for a minute about how Parasoft Jtest generates unit tests. Basically, we use an AI technology to generate these tests. Whether we're generating tests for legacy code, we have other actions that allow developers to point at a line of code and generate a test for that hits that line of code and so on. And basically, the way it works is all this technology goes through this process. So underneath the hood, we have our patented flow analysis engine that can analyze all the different paths through the code, understanding what's possible and how the code can be executed. Once we have that model, we're able to generate what we call a recipe. So the recipe encapsulates, each path through the code, plus the different constraints on the variables that need to be met in order for, the flow to reach that part of the code. Once we have those recipes, we evaluate and score them based on different criteria, such as, how much code coverage do they give us? How complex of test cases are they going to create? How much mocking will be required, and so on. There's a number of different criteria. And then once we score those recipes, then we choose the ones that score the highest, and we solve for specific variable values that match the constraints. We generate the code, and then we actually execute the code to do two things. One is to make sure we measure all the coverage for all the tests that we create. And if there's any tests that are creating redundant code, they're redundant tests, so they're covering code that's already been covered by another test, we'll make sure that those get removed. And then we capture the current state and add assertions to the test. So through this AI-led process, we're able to generate a meaningful test that looks like a human wrote it. These tests are not, they're using just standard open source JUnit, Mockito type frameworks, and they can run completely outside of our product in a CI/CD process. So in general, if you use this technique to generate tests for your legacy code, it gives you a lot of confidence that you're able to make changes to the code and not worry about breaking stuff. In our own development, we use this practice. So even within this past year, we've been addressing some violations found in our OWASP top 10 rules, our static analysis rules. And some of the issues that we needed to address were actually in legacy parts of our application. And so we use Jtest to generate tests in that part of the code to make sure we had high levels of coverage there. And we've also had multiple customers who have done the same thing. They had some project where they needed to, say, modernize their application. They had no tests. And so before they started, they used Parasoft Jtest to generate the suite of tests, which then gave them the confidence to go ahead with the project they needed to do. All right, so the second technique I want to talk about, one that I get very excited about, and I think is very important to our organization, and I think every development team should use it, is modified code coverage. So what often happens, especially in a legacy application, is you have a lower level of coverage. You might have 40 or 60%. But you want to have a better practice, right? You want to create tests as you develop your code. You'd like to enforce, say, an 80% code coverage metric, but if you have 1 million lines of code that are covered at 40%, how in the world do you measure that your teams are writing tests as they go? It's really hard to do, unless you use a technique like modified code coverage. So what this technique allows you to do is set your coverage target and say, well, I'm going to measure the coverage just for this new and this modified code. And you can do it at a sprint basis. So where you say, yeah, by the end of the sprint, every code I changed in the sprint needs to meet the coverage goal. And we do that. Or you can say, or actually I should say, because we do this as well, for the release cycle, you would say, well, for my entire release cycle, I need to meet this specific coverage goal, say 80%. What this does is allows you to focus your testing efforts on just the code that you're changing. If you have parts of your application that aren't well tested, for the time being, you can kind of close your eyes and ignore that and just focus and say, any code I'm touching, any code I'm changing, that's going to be well tested. It allows you to build in those good development practices that you want to enforce on your teams. It gives you confidence that the functionality you're writing works well. And then the real nice benefit is if you maintain this practice over time, you'll see that if even if you start with a low level of coverage in your application, over time that coverage continues to go up and up and up and up. Slowly but surely it goes up. And we've seen that work really, really well for us. And I mean, it's not just a technique for legacy. You could, it also works for new projects. I mean, this is the same kind of thing. If you have a new project that has a very high level of code coverage, maybe it's meeting your goals. It can be hard to notice if for one sprint or for a certain set of user stories, whether a team didn't do any testing, right? And again, modified code coverage will help you measure, like for that sprint, did the team, write the appropriate level of tests. Now, when we talk about modified code, in addition to being able to help you measure your modified code coverage, Parasoft Jtest helps developers optimize their workflows around handling the code that they're modifying. And it does that in two primary ways. So as you'll see in a moment, Jtest is installed in the IDE where the developers work, where they're writing their code. And one really neat feature is that when they have changed code, it allows them to generate unit tests that are optimized to cover just the code that was changed. And not only does it handle just the code that was changed, but when it's during the generation process, it'll identify if there's any existing tests that cover that. And in fact, it will only cover the changed lines of code that already have no tests. And so it's highly optimized to focus on the untested parts of your code that you've recently modified. And this practice, it makes the unit test creation process much more efficient for the development team. The second thing that teams can do is, when they change code, they often don't know, before they submit their pull request, they often don't even know which tests to rerun. So either they rerun the wrong tests, or sometimes they don't run tests at all because they don't know what to do. So we have the Jtest plugin has a functionality that will identify for them, this is the set of tests that touch the code that you just changed. Run these tests before you commit your code. And again, it's a big efficiency booster, and it helps them identify and run the tests. And Brian will show that in a minute. One of the things that makes our Parasoft Jtest so unique is that we have a combination between automated test generation and what we would call assisted test creation. So, I've been talking a lot so far about this automated test creation, where based on a set of source code, we'll generate you a set of tests. And I mentioned, you get to 60 or 70% coverage in a lot of cases. 60 or 70, though, doesn't meet what most people's goals are. And really the issue comes down to any automated unit test generation tool today, that's around the limits of what it can get. However, I mean, that's still good, right? It still lets me, with within a few minutes, achieve a fairly high level of coverage. But we know that, automated tests that are generated like this, I mean, they're optimized to cover all the different code paths, but, they don't necessarily have all the specialized knowledge that a development team would have about, what are the most accurate values to exercise this code with real world use cases. So typically in that case, what we suggest is you use this as a starting point, and then developers can go in and tweak the tests and make them a little bit better, make them more tailored to the specifics of what they know they need to test. And this is where the assistant part comes in. In addition to this sort of automation, we also have a lot of helper functions and assistance functions in Jtest that will allow teams to do things like, one of the most complex things is generating mocks, right? Writing mocking code when you need to mock out some object that you don't care about testing, but is involved in the code that you're testing. Generating that mocking code can take a long time, and sometimes people don't know how to do it. And so, having helpers that help you generate those mocks can really be a big time saver. And our teams have told me about how they use it to do that. And so, and that's just one example. There's a lot of different helper functions that are there that will help the developers be more efficient as they either enhance the tests that Jtest generates to get higher levels of coverage. They might need to add in some additional tests with some specialized logic, but this assistance technology will help them do that more efficiently. And in the end, with both this combination of autonomous plus assistance, teams can reach the coverage goals that they have for the application. So the third technique that I want to talk about is optimizing your test suites. So if you actually commit to a unit testing practice, I mean, over time, you're going to generate a larger and larger suite of tests. And again, if your team is like ours, some of those tests may be more complex. We have some tests that are written in unit test frameworks, but they're more like integration style tests. They might take a longer time to run. And if you combine sort of the sheer number of tests we have to run, plus the fact that some of them are these more integration style, higher level style tests, the entire test run sometimes takes a long time to run. And in many cases, that's too long to run in your CI/CD process, because in your CI/CD process, you want to have a pull request, you want to quickly validate, okay, I didn't break anything, and so that you can then integrate that change into your main build and move on. And so the main test suite often takes too long for that. So to handle that, we can use a technique that's called test impact analysis. And basically, the way test impact analysis works is that it understands the code that each test in your entire test suite covers. So you have your big test suite, it covers the code. When you run your full suite of tests, it analyzes and understands the relationships between the tests and the code that they touch. Then when you make changes to your application, it determines which code changed. And then lastly, once we know which code changed, then Jtest is able to identify the specific set of tests that need to be rerun to validate your changed code. And then it would run just those tests. If we look at an example, this is actually something that we captured off of one of our Jenkins build servers. So you see on the left, we have a full test suite that had close to 4,500 tests, and it takes a certain amount of time to run. On the right, we took that suite of tests and we optimized it with test impact analysis. And this was a historical chart of how that job ran. And you can see that we were anywhere from average was probably somewhere in the 25 to 75 range as far as number of tests that were run. So it cut it down from somewhere around 4,500 to somewhere in the 25 to 75 range, right? A significant time improvement. So we've seen that when using test impact analysis, you can reduce the size of your test suite by 90% or more. This isn't to say you shouldn't still run your full test suite. You should still run it nightly or on a very frequent basis. But during the day when you want quick feedback on a pull request, test impact analysis is the way to go. The last technique that I want to mention is that it can be very effective to measure your code coverage across all of your different testing practices. So, we're focused on unit testing today, and unit tests often make up, the majority of your tests. But, or at least a lot of people would argue they should. We found that unit tests are not always the most optimal test to cover specific code, right? Sometimes there's certain code that really the most optimal test is a UI test, even though we don't want that many UI tests because they're more brittle and they take longer to run. Some tests, UI tests, or some code, UI test is the right test to run. And so we have, we have unit tests, we have API tests, we have different styles of functional tests, and we have UI tests. And we will take all the coverage data, we'll collect the coverage data across all of those different test runs, and we'll aggregate that to give us an overall metric as far as the code coverage for our application. And so it can be sort of the overall coverage, and that can also be used as input to the modified code coverage that I mentioned. And so what this allows us to do is to create the right set of tests, the right kinds of tests, so the optimal set of tests for the code that we're testing. And again, it's another way that it saves time, because now I say, well, if I'm covering a certain part of code with an API test, I don't necessarily need to go and write some unit tests for it. I mean, I might have reasons to do that, but there might be many cases when I don't need to. And so that's another way I'll save time, because I'm able to measure the coverage across all of my practices. So with that, I am going to turn it over to Brian, and he's going to give you a little flavor of what it looks like, just from a very high level, what the workflow would look like to use some of these techniques as part of their development unit testing workflow.
All right, thank you, Nathan. I need to go ahead and share my screen here. Hopefully you can see my screen and hear my voice. I apologize, my voice is a little strange today. So I would like to start by showing our reporting and analytics dashboard. So this is an example of what developers or managers might see while they're working on a project. And here we can see some useful widgets which provide visibility into various aspects of our project's health. So for instance, you can see the aggregate of all the tests. That's currently providing about 64% overall code coverage, which is a bit low. And then I have a breakdown of where that coverage is coming from. So I've got unit tests, I have functional tests, and so on. I also have a widget and a few other widgets actually that are dedicated to modified code coverage, which Nathan mentioned before. So that's coverage for code that's been recently modified, right? And modified code coverage is particularly helpful in understanding whether developers are writing new tests or updating existing ones as the application changes, right? So it looks like we have just under 70% modified code coverage. So if our goal is going to be to reach something like 80%, then we know we need to add more tests, specifically during the spring before we consider it done. And I can also do things like I can click on the widget. I can see specific gaps in code coverage, for instance, in the modified code coverage. And then as a team, we can talk about those and we can fill those gaps using our tools. So the reporting and analytics dashboard provides us with the visibility into those metrics that we're using to measure and then achieve those team goals and policies. So I want to also look at Jtest and the unit test assistant to get an idea of how we use it in our projects. Now, this is a tool that's integrated into the IDE where the developers are working. So it's going to be a plugin for either Eclipse or IntelliJ. And here I'm using Eclipse. Now, I have this project which has a whole bunch of testable code. And sometimes for instance, legacy projects, there might already be a lot of, or there may be no existing tests, I'm sorry. So in that case, what I'm going to want to do is use Jtest to generate a suite of tests to cover as much of the existing functionality as possible. I can do this by basically right-clicking on the project, and there's a unit testing action, and I can go to Create test suite. This is going to figure out what there is in the project, look at all the files it's going to need to generate tests for, and then in the dialog, I'm going to be able to configure some of the preferences here. Oh, my machine is a little slow this morning. There we go. This is going to allow me to kind of configure how I want those tests to be generated. So maybe I'm going to want to maximize code coverage. I'm going to want to configure mocks in a specific way, and so on. And so I can click OK to go ahead and do that. Now, I'm not going to do it here because it takes a little while, especially for big projects. But what Jtest will generate is a fully configured suite of tests which validate all of the existing project functionality. So this is great for legacy projects that have either no tests or very few existing tests, and so there's very low code coverage. So you can very quickly use that to jumpstart the project to get to 60 or 70% coverage. Now this project is actually under active development, so it does have a bunch of existing tests in it. And in cases like that, which we see a lot, as we make changes to the project, we need to make sure that the existing tests that are there are being executed as early as possible and as often as possible, preferably before our developers are actually making commits, right? Committing changes, because we want to be able to find and prevent regressions before they get pushed. The problem is that if I try and run and update tests manually each time I make edits, that's going to be a very time-consuming step, right? And because it's time-consuming, our developers often find themselves skipping it or shortcutting it, right? And then they don't find issues until after they commit their changes. So instead of doing it manually, what we actually do on our teams is we use the unit test assistant to help us improve that workflow and then reduce the amount of time that we spend maintaining those tests. Now, one thing I want to show you also is for this project, I've imported the coverage data. This is actually the coverage data that came from the analytics dashboard we were looking at before. So Jtest already knows which existing tests cover which lines of code. So what I'm going to do is I'm actually going to make some changes to the code so that we can see how easy it is to find and run the tests that are being impacted by those changes. So here I have a method, basically adding an object to the database. Let's just make a quick edit here. So I'll just add a little bit of logic. And what this does is it says if you want to add a customer to the database, check its ID first, because if it's already set, maybe we don't need to add it to the database, right? So I just changed the behavior of the application. So now that I've made changes to the application, I need to verify that that change is being properly tested. One way to do that might be to run all of the tests in the entire project, but that's going to take a while. And often what we see is that developers just don't want to wait for all those tests to run for each and every edit. Now, I could also look for a very specific test class for the code that I just modified. For instance, for this class that I just changed, there's a little action here in UTA. I can go to the test which is dedicated specifically for this class, and I could just run all the tests in that class. But there might actually be other tests that are that would be affected by that change. So what about any other tests in the project that might detect an unforeseen regression? Now with Jtest, I have this tool that I can use, which is the impacted unit tests view. And this view is populated dynamically as I'm making changes to the code. So if I take a look at what's here, I can see that it's populated with a number of tests, actually. The one that I was just looking at is there, but I also see tests in service package and in web.controller package. So these are all tests that I should be running before I commit my code changes, because these cover the modified code. And what I'm going to do is I'm going to go ahead and run all of those impacted tests with this run all action up here. So Jtest is going to do what it's going to create what we call a smart commit suite. It's similar to classic commit suites if you're familiar with those, but what it does, it selects the specific tests which are impacted by my local changes. So once that run is complete, I'm going to take a look at the results there. And it does take a few minutes because this is a Spring application. Oh, and my machine, once again, is a little slow this morning, so apologies for that. But yeah, when this is all done, what I'm going to see is that I'll be able to see the status. There we go. I'll be able to see the status of the executed tests over here in the impacted unit test view. So I get a nice, convenient view of all of the impacted tests and the results. I think my machine needs another cup of coffee. It's definitely taking a little while. Okay, so sorry that took a few minutes. Actually, I just noticed, so as this is running, I just noticed that we actually have a test failure, right? So one of the tests failed, and that's caused by the change that I just made to the application. And it isn't in a test that I would have guessed to run. So without Jtest, I probably would have seen this if I had run all of the tests in the entire project, right? Or maybe it would have failed in my CI/CD or a nightly run. But here I was able to find it much sooner. And now I can either fix the application code or the test before committing my change. And even though it did take a few minutes to run, it's still a lot faster than running all of the tests in the entire project. So another thing that's important to do when I'm making application changes is to make sure that I have new tests to cover new code, because I want to keep my overall code coverage numbers and my modified code coverage metrics high. So in this case, what did I add? I added a new code path. So I should add a new test specifically for it. Now I could do that without Jtest, but what I'd have to do is probably create a new test from scratch, or maybe find an existing one and then reuse and extend it. But I need to know which test to reuse and how to configure that new test with proper values or mocks or any of that stuff. And it's common for when I'm making code changes to make multiple edits to multiple methods and multiple classes. So there's a bunch of different changes in a bunch of different places. So I'd have to repeat that manual process for all of those different things that I've modified. But instead of spending lots of time doing that manually, Jtest can do that for me automatically. So let's go back to the project, and I'm going to do what I did before. I'm going to right click on the project again. I'm going to go to unit testing, and I'm going to go to create test suite. So now instead of creating tests for the entire project all at once, I'm going to focus test creation on just the modified code. Once my dialog comes up, there we go. So I'm going to maximize my code coverage, but and keep the same mocking settings. But you notice here there's an option where I can create tests either for the entire selection, which would be the entire project, or like I said, modified methods only. So Jtest detected that I had one modified method, and now I can run test generation just on that. And I'm going to go ahead and do that since that's going to be a little bit quicker than doing it on the whole project. So what Jtest is doing is it's analyzing the modified code. It's going to create tests to fully cover those changes. And then it's going to run the resulting tests so that it can optimize what it generated. So it'll pre-configure that test. It'll add real assertions and real mocks to it, and then it's going to clean up any of the unnecessary stuff. So Nathan already explained in a little bit more detail what that process consists of. But yeah, that's what it's doing right now. Yeah, so it's going through the step of creating the test, and then next it's running the test. When it's all done, it's going to tell me, it's going to report what it did. Wow, I apologize. My machine is particularly slow this morning.
Need to wake it up.
Yeah, I was doing this before and it took a few seconds. So I don't know, maybe all of my caches got dumped overnight. Okay, so it went ahead and it finished, and it tells me what it did. It created a couple of new tests. So it found a couple of new tests that it could generate to cover that new code. Yep, and if I go to the test class, I'll be able to see that, yeah, it went ahead and generated some new tests. And I won't bore you with all the details, but one other thing that I will show you is that after it generated the new tests, it also added them to the suite of impacted unit tests. So now these are included as new tests that I should run and make sure that they're passing before I commit any of my changes. So for our development teams, these workflows do save us a lot of time in creating and maintaining tests for both legacy and active projects, which makes it a lot easier for us to meet our team goals and our policies. And I've only touched on a couple of the actions that we use that save us time, but there's a lot more to Jtest that we don't have time for today, and the unit test assistant that they can do to save us time. And with that, I'll hand it back over to you, Nathan.
Awesome. Thank you so much, Brian. All right. So just to recap, today we've talked about 4 techniques that you could use to enable your development productivity, specifically in your unit testing practice. So we talked about generating unit tests for uncovered legacy code. We talked about measuring and enforcing modified code coverage goals. We talked about optimizing your test suites and your CI/CD process. And then we talked about measuring coverage across all of your different testing practices. When you use these kinds of techniques, you don't just have to take our word for it. We've had customers tell us that they've reached, up to, and some customers told us even more than 50% reduction in the amount of time it takes them to create unit tests. We found that you get 90% or more reduction in the amount of time it takes to execute your unit test suite in a CI/CD process. With these techniques, you can enforce good development practices and make sure you get the high levels of code coverage you need using modified code coverage. And using that technique, you can continue increasing your code coverage across all of your tests from all your testing practices, and continually improving the amount of testing you have in your application. So in summary, we've seen how Jtest and the Unit Test Assistant can simplify the creation and maintenance of unit tests, enabling developer productivity. One thing I didn't talk about today too much, but it does also come with a very good static analysis engine with over 1,000 different built-in rules, including a number of different security standards. So we and our customers also use that functionality to validate our code. And as Brian showed, Jtest is integrated into your existing development environment, whether that's in your IDE as far as like IntelliJ or Eclipse, or it's inside your CI/CD build system, and that would be Azure DevOps or Jenkins or whatever. We easily integrate into whatever you might be using. One thing that we just recently launched that we're excited about is that Jtest now has a free trial. So there's a 14-day free trial that you can get, and you can try it out for yourself. So you can test out, see how it creates unit tests. You can look at the test impact analysis, the thing that Brian showed with the impacted unit tests. You can look at the static code analysis and so much more. So we've got the link here, but if you miss it, you can just go to our website. It'll be easy to find. Sign up with your email, and you'll be able to get a free 14-day free trial to try it out. So I really hope that you'll do that. And also at our website at parasoft.com, in addition to the free trial, we have an ROI calculator to help you measure the productivity gains you might get. We have a case study and a lot of other great information. So with that, I'm going to wrap up. We're going to thank you for watching our webinar today. And I guess we'll stop here and see if there's any questions that anyone has for us.
Yeah, great presentation. I'm just going to hop back on to facilitate audience questions. If anyone has any questions you'd like them to answer, just put it in the chat and we'll get it answered for you. I guess to start, can you talk a little bit about how sprint data can be used to improve quality?
All right, hopefully my mic still sounds good. Something switched when you came back on, so I hope you guys still hear me okay.
Yeah, we can hear you.
Okay, great. So how can sprint data be used to improve quality? Was that the question?
Yep.
Okay. So, I mean, a lot of that comes down to what you measure as part of your development process, right? So, I mean, the modified code coverage was one thing that that I mentioned, where if you measure your code coverage, especially on your modified code, as you go through your sprint, we'll often review that, especially as we get towards the end of the sprint. We'll review that number and say, oh, are we meeting the goals? No, we're not at 80%. Okay, let's go back, figure out which classes did we not cover. Let's add tests for those. And so that's just one example of how if you measure that data, then you can actually use it to enforce the quality. So when you get to the end of the sprint, you can verify, okay, my user story has appropriate levels of testing. So that's just one example. Another example here is, I mentioned we're using static analysis. So, we're constantly, we're looking at the static analysis results every day. So if somebody introduces code that breaks one of the rules, we fix it immediately. So I guess those were two examples of how you could use data to sort of improve the quality of your application.
Another question that came up is, what's the pricing look like?
So yeah, from a pricing, I'm more on the development side, so I'm not the right person to answer that question. We have the free trial, so I would highly encourage people to go try that out. If it looks like something good for you, as part of that trial process, you'll be connected with someone at Parasoft, or if you want to just go to our website and directly connect with somebody, you can do that. There's other folks on that side of the building that'll be helpful. They'll be better to answer that kind of question.
Got it. Another question that I see here is, can we write custom methods for objects that we may want to use during test generation?
Okay. Yeah, that's a great question. Brian, do you want to handle that one, or you want me to do it?
Yeah, I can answer that one. So, I mean, the answer is yes. So this is one of the examples of customizability that we have in Jtest. We call them factory methods, basically. So the idea is that as you're writing more and more tests, you might find that certain objects, you want them mocked in a particular way, and many tests are going to want to have these objects set up in a standardized way or mocked in a standardized way. And so one thing you can do with Jtest is write a factory method, and then what you do is you annotate it, or sorry, not annotate it, you tag it so that Jtest knows about it. And then when you're generating new tests in Jtest, it will find those tagged factory methods and it will reuse them whenever possible. So, let's say you have some customer object and you want it to be reused over and over again. You can tag that, and then anytime Jtest sees, oh, I need a customer object to pass to this method or that method, it'll use your tagged factory method. So by building up a suite of these tagged factory methods, you can sort of train Jtest to write tests that are specifically configured to the needs of your application. Yeah, good question.
Can you also talk a little bit about how the test impact analysis feature identifies redundant tests that can be removed?
Interesting. Okay, so that's actually not specifically the goal for test impact analysis related to redundant tests. It's optimized around finding the optimal set of tests to run based on code changes. But I think we mentioned it previously. When we do when Jtest is generating unit tests for you, it's optimized around preventing these redundant tests from being added in the first place. So if you say you have a project and you have a set of existing tests, maybe you even wrote those by hand, you can tell it, well, I want to generate tests for this project, but it will be optimized so that if you have tests that cover certain parts of the code, it's not going to create new tests for that already covered code. So, during the test creation process, we're trying to optimize and not create redundant tests from the beginning. Yeah.
Got it. That makes sense. How do you capture code coverage from manual testing?
For manual testing, so basically, our product comes with what we call a coverage agent, and so basically, what you can do is you can attach that to your application. This is sort of outside the bounds of unit testing, obviously, but you can attach it to the application, and then as you we have a sort of a helper application that we call Coverage Agent Manager, but you can use that to basically tell it when you're running, I'm running test A, I'm running test B, I'm running test C, and it'll connect to the coverage agent and capture the correlations between what test is being executed and which code is being executed. And then we have little tools in Jtest that will allow you to capture that code coverage and upload it to our analytics dashboard and combine it with all of your other coverage results. So it's all part of kind of this holistic workflow.
Awesome. It seems like we've answered all the questions that have come up in the chat so far. So I guess we can just end it here. I also did want to note that someone asked if a recording will be available for anyone who joined late. And yes, there will be an upload on the SD Times website probably later today. So you'll be able to go back and watch all of the session. Thank you both for this great presentation, and thanks to Parasoft for sponsoring today's webinar.
Great, thanks everyone.
One more question that we can just answer real quick. From Samuel, okay. Can Jtest call out deprecated methods?
I would think so. From that, I think we could configure our static analysis engine to find the deprecated methods. So yeah, definitely.
Oh, and another question just came in too. Are there similar tools for other programming languages like C, C++, etc.?
Mm-hmm. So yeah, we do have other language products. So we have a C++ test. We have a dot test for .NET. Unfortunately, they don't have the unit test generation capabilities. C++ test does have some unit test generation capabilities, but it's a little different than how it works for Java. It's a little bit different, and I'm not as familiar with the C++ side of it. You'd have, you could feel free to reach out to us and learn more. But the unit test assistant technology that we talked about today, as far as generating tests, is primarily for Java. The code coverage parts, as far as measuring modified code coverage or aggregated code coverage, that is available for all for other languages. So yeah, I guess the answer is it's mixed, right? Depending on what you're looking at.
Mm-hmm. That makes sense. Great. So yeah, I think we got it all, and we can just wrap this up now.
Awesome.
Thank you.
Well, thank you all very much.
And thanks for everyone for joining in today.
Yep.